Welcome back to unusual GCSE maths questions.
Okay.
This is an unusual question. We'll put it up on the screen for you now. Have a look at it, have a go, and then come back. Okay?
Okay, so we're not quite sure where this question is from. We know it's some sort of Edexcel
We'll find
GCSE.
it.
Yeah.
By the time I upload it, I'll have found it.
Fingers crossed. Yeah. But if not, it's still a good question. Okay then, may you start?
Right, so you can't really tell from my diagram, but these three triangles are all supposed to have the same angle in here. It's not too bad, is it really? It's not too bad. We've got to prove that y is 3/4 of n, so that this is 3/4 of this.
So it's one of those questions where I think you're just going to go with the flow. Let's just see what information we have. You can see that all three of them are right angle triangles. So if it's right angle triangles, probably going to be something to do with SOHCAHTOA, I would have thought. If we've got missing sides and we've got angles. So I'd probably just start with that.
So should we say, it's like, this is a great example of a question where, like Grace just said, you don't have to see how to do it before you start. You just start and see what happens. And what will happen is you'll get to the end.
Yeah. Okay, so shall we look? When you're doing SOHCAHTOA and you've got, you're trying to work out values of different triangles, if the triangles are joined, I'm not explaining this well. If the triangles are joined together, I'd always try and work out the shared sides. So anything that's shared between the two triangles is probably a good place to start.
Because you're gonna make your way like a little journey across the triangle from one to the other. Yeah.
Do you want to start from this side to that side, or that side to that side?
We will. That's another thing. I mean,
I went from this way to this way.
You see, I would be tempted to go from this way to this way.
Well, let's do that then. Okay, so what I'm going to do is I'm going to call this A and this side B.
So give things that you think might be useful some names.
Okay, so first off, let's look at this first right angle triangle. We've got a 30-degree angle, so here, this is opposite the angle, and then this is clearly the hypotenuse. So if we've got an opposite and a hypotenuse, we know, so I'm going to put step one, we know it's so, which means that it's sine of our angle, sine 30 degrees, and the opposite is y, and the hypotenuse is a. There was something else that we didn't mention here actually. This is a non-calculator question, okay? So, really important. Here, we want to work out what A is, right? Because this is like our journey through to the next triangle. So if I rearrange this, that would give me A equals y over sine 30. And because this is a non-calculator question, and we should all know our exact trig values, we now have to plug in what sine 30 is. So that's a half, isn't it?
It's a half, yeah.
Yeah, okay. So we know if we're dividing by a half, that's the same as timesing by 2. So A equals 2y.
So should we just think for a few minutes about how we're going to find out what sine 30 and 60 and things like that are if you don't have a calculator.
Yeah.
So there's different ways you can do it, but the most popular way probably is to remember if you have an equilateral triangle and the side length of that equilateral triangle is 2 and you split it down the middle, so that now has a length of 1. Pythagoras' theorem says that that squared plus that squared equals that squared. So this squared, which is 1, plus this squared must equal 4. So that means that's got to be the square root of 3. Not that we actually need that for sine, do we? Because we've got 60 degrees here, because it's equilateral triangle, 30 here. So this tells us that the sine of 30 is 1 over 2, which is a half. So at this point here, you could just, because sine of 30 is a half, rather than do this, you could just say, well, y is a half of a.
Yeah, you could.
And then, which is where we are here.
Yeah.
So,
yeah, the same thing.
However, so should we clear some space?
No, keep it, because I
until we need
feel
it,
like
right.
we might need other trig values, but that's just,
Okay.
I'd say it's my intuition, but I've done the question. Okay, so here we know A is now 2y, so on my diagram I'm going to replace that. Okay, so I'm going to put that as 2y. So now we've moved on to our second triangle. So we've still got the angle here, so we don't have our opposite, we have our adjacent and our hypotenuse, which means those can. So on cos of 30, there we go, so we do need the triangle stuff, equals adjacent, which is 2y over b, and then cos 30, so we're going to go back to this triangle. So cos is adjacent over hypotenuse, so that's root 3 over 2. So here, I'm going to do the way Matt did it. Root 3 over 2 equals 2y over b. And then what are we trying? We're trying to get b, aren't we?
Yeah.
So, yeah.
Just like here and up here.
Yeah, go for it. Yeah.
Okay. So we've got root 3 over 2. So that means, just write that again. Root 3 over 2 is 2y over b. So if I do what Grace did before and now we replace b with some kind of an expression to do with y, let's cross multiply, maybe?
Yeah.
Cross multiply is firm, isn't it? 2 times 2y is 4y. So we've got b is 4 over the square root of 3 times y.
And I'm going to replace that up here. Okay, so what is it? 4 over root 3 times y. Okay.
And then we've got the last bit, so we've got the tan of 30 is n over that, because it's opposite over adjacent, isn't it? So we've used sine, cos and tan in this, using this particular method. So let's just say tan of 30 equals opposite over.
Cool.
Right, now tan of 30 is 1 over root 3, which is the same as root 3 over 3 if you were rationalising, but let's not. So we've got.
Well, if you do, then the root 3s are going to cancel.
Yeah. Oh, shall I then? Shall I? Okay. Okay.
Yeah, what he's trying to say is 1 over root 3, if you rationalise the denominator, you get 1 times root 3 is root 3, and root 3 times root 3 is 3. Okay.
Okay, so now we're here, and if I cross multiply again, I'll do, which way shall I go first? 3n, and if I've got 4 over root 3 times root 3, that just gives me 4 times y, which means that y, that's what I'm trying to do, yeah, y, I'll divide through by 4.
Yay!
And there we go.
Happy days.
So,
That's a beautiful question.
it's a fun question, isn't it?
Yeah.
What's the moral of the story?
Go with the flow.
Yeah, don't worry about how you're going to get to the end when you start, just start and learn your triangle.
Yeah.
Yeah.
You need your exact trig values.
Yeah.
Okay.
Apart from that, that's it.
Cool.
Any other interesting questions you want us to look at? Unusual questions? Let us know and then we will do that.
Bye.